Hello friends, look at this beautiful exercise we have here, very interesting. As always, you can solve it in your notebook and leave me your answer in the comments. The exercise says that if the two figures are squares, find the shaded area. So we have a square and inside we have another square. And we have to find the shaded area. That is the area of this circle. But to find the area of the circle, we need its radius. That's what we're going to look for right now. I'm going to erase this shaded part for a moment and I'll bring it back at the end. So take a look. Alright, here we have that the area of this triangle is 24 square meters and that the area of this square inside the large square is 100 square meters. So first, let's analyze the triangles to see if they have the same area. So here we know that there are 90 degrees because it is a square, right? So here we are going to say that this is something, an angle A. And we're going to name this angle here angle B. So the three angles of a triangle must add up to 180 degrees. 90 plus beta plus alpha make 180 degrees. Here we also have a square, so this also forms 90 degrees. So from here to here is a straight angle that must be 180 degrees. If we have 90 here and beta here, how much is left to reach 180? Well, we need alpha. See you.
Well, it's going to be something here over here.
Also, we will have 90 degrees. And here how much is left to have the 180 degrees of a triangle? We are missing angle beta, and this will continue happening here. We will have 90 degrees here. We will need alpha here. Here we will have 90. Here we will need beta. We have 90 here. Here we will need alpha. And we have 90 here. And well, here we will have 20. Fantastic. All the triangles here are similar triangles. So they all have an area of 24 square meters. Including this triangle inside this circle. Let's erase these angles for a moment because they won't be useful. They were just to know if all the triangles were similar. Now what we're going to do is draw a line from the center point of the circle to here. Towards the tangent point where they intersect. On this side of the square with the circle, this is a tangent point, and over here we also have a tangent point. This is where the circle meets this line here, and we also have a tangent point here. Very well. Here you will see 90 degrees because it is a line that goes from the center to the tangent point. 90 degrees are formed here. Here is a cone here. Here they will also see 90 and here also 90. Alright, we can draw a line from here to the center point of the circle like this. Alright, and since this line here, notice it forms a right triangle here. And down here a right triangle is also formed as this line here is tangent to the circle's antecene. And this line here is also tangent to the circle and they join here, so we can say that this side is same on this side here. That is, this distance here is equal to this distance there. And since they share the same hypotenuse, we can say that the area of this triangle is the same size as the area of this triangle down here. We can do the same thing up here. We will pass this red line and connect from here to the center of the circle, so they are also formed around here. Two triangles here have 90 degrees as I had said, and here there are also 90 degrees, forming two equal triangles again. So this red triangle here, it has the same area as this red triangle over here, and here we have a square. So pay close attention. This spot here, which were the lines that reach the tangent point, we are going to call R. See, so this part is R. And if this part up here, which is parallel to the part down here, is down here, it will also be R. And if this part here is R, here it will also be R. So let's paint this square blue. And look, the area of this whole triangle is these two green triangles, these two red triangles, and also at this square. Now pay close attention to this triangle here that I am showing you. We are going to draw this triangle here, but we are going to turn it this way. That is, these 90 degrees will be here. At the base 90 degrees, this part here is what I'm going to draw right now. Look, like this. And this part here, which measures r, that we said is the radius of this circle, we'll draw it upwards so it looks like this. And over here is the hypotenuse. Well, obviously it's this part here. Very well. We have already drawn this triangle and we flipped it over here. Now we can also flip this triangle here in such a way that this part is upwards. That is, these 90 degrees will be here in this skin. This part, which is the radius I will draw right now, is here. And this part here is going to be this part down here. So we will have it up here. Very well. Alright, this part is this part, and so this is r, and this part here is also r, so we'll put r here. And the same we can do with these red triangles that have this part which is r, and this one also which is r. See now, we are going to draw this triangle here by rotating it this way. It's going to be 90 degrees here. This 90 degrees will go here. And then this part here is this part here, and this part over here is this part here that I'm going to draw. And this hypotenuse is this part right here. Very well. And we can do the same with this other triangle because they are the same size. So we can turn it this way. So these 90 degrees will be up here. So this line here is going to end up here. And this line here will stay here. Fantastic. We ended up with a rectangle, and this is also r because it's this part right here. We ended up with a large rectangle because it has the same height. We can join the two rectangles to get a large one. And this part here is 10 meters. As we know, look, this base of the green triangle is this part here. So if we join the two bases, we get 10 meters. Because the area of this square here is 100 square meters. That means each side is 10 meters. Okay, great. We have 10 meters here and 10 meters there. And we can find the value of r, which is the radius of the circle. How are we going to do this? Look, here we have two green triangles. Which are these two green triangles?
We have two triangles.
Reds, which are these two red triangles? We just need to add this blue part, which is a square with side r. And adding up all these areas gives me 24 square meters because all the triangles had the same area, right? So, let's add it. The area of this large rectangle is base 10 by height. It's the area of this rectangle. Now let's add this area here more. The area of this square is side by side, which means r by r, giving us r squared. So the sum of all these areas has to be 24 square meters. We simply write 24. And in the end, we are going to write the units. So let's keep this organized. We have r squared plus 10r on the left side. And this 24 that is on the right side, we will leave it on the left side as minus 24. Then it is equal to 0. We have a quadratic equation that we can solve with the general formula or by factoring. In my case, I am going to factorize because it seems to me that it is the easiest. So, in each parenthesis, we will put the square root of this term, which is r. In the first parenthesis, we will put this sign. And in the second parenthesis, the multiplication of these two signs. Plus times minus gives me minus. Now pay close attention because we need two numbers that multiply to give us minus 24. and that added or subtracted gives me 10 possibilities. Those numbers are 12 and 2. 12 times minus 2 gives me minus 24, and 12 minus 2 gives me 10 positive. Now as both are multiplying and are equal to 0, I can set each parenthesis to 0. R plus 12 equals 0, and here R minus 2 equals 0. This equation doesn't work for me because when I solve for R I get minus 12. And well, we don't have negative distances, so only that equation works for me. By clearing R, I find that R equals 2 positive. 2 meters because we are talking about square meters, fantastic. We already have the radius of our circle, and now we can find the area very easily. The area of the circle is pi times radius squared. The area of the circle will be equal to P. And what is the radius? It is 2 meters then. And the square tickets here, we see that the area of the circle is going to be equal to. So P times 2 squared gives me 4, so 4P. And everything square meters. Fantastic. We have already found the solution to our exercise. The shaded area of this circle which I have returned, it's 4 pi square meters now. If you want and wish, you can multiply 4 by 3.14. So you're going to get a solution more or less, right? So you're going to, now the area of the circle will be 12.14 square meters. Here we have to notice that it's not equal but approximately, because we have more decimals. So here we have the decimal solution, the exact fantastic solution. Let me know in the comments if you liked the video, and don't forget to subscribe and give it a like so you don't miss the next challenge. See you another time. Bye and